Welcome, friends, in this MOOC course. Up till now, we have discussed about gamma function. We will recall this. Now we are knowing the definition of this gamma function is integration 0 to infinity or minus power n minus 1. Then we are knowing gamma of 1 is equal to 1. Gamma of n plus 1 is equal to n factorial. N is or zeros, and this is gamma of n plus 1. Otherwise you can write n into gamma. Also, we are knowing that gamma of 1 by 2 is equal to root of. And we have solved number of problems based on type. Suppose I have this integration 0 to infinity e raised to power minus kx into x raised to power something n into dx. We know how this works. In this case, we have to put this factor as a t, and then we are getting solution. Then type 2, integration e raised to power. Suppose the square terms are there, and here this is just like square term or cube term or power is same type, but maybe this type x raised to power a divided by a raised to power x. In this case, we have to put a raised to power x is equal to something e raised to power p, and then this. And type 3 integration 0 to 1 x into log x raised to power n or m. Type, then you can put log x equal to, if you're putting this way, then you can find anti solution. Integral equation. Now I will move towards the next part, and we have discussed here under improper integral that integral 0 to 1 x raised to power m minus 1 into 1 minus x raised to power n minus 1, and we are knowing that this integral function is converges for m is greater than 0 and n is greater than. And now I am defining this function as a beta function this function is denoted by beta mn is equal to integration 0 to x raised to power m minus 1 into 1 minus x for minus 1 into dx. And this converges for n greater than 0 and n. Therefore, I will write here beta function. Now I will go to tested results beta function. Or before that, I will write here some particular. I will put particular value beta of 2 3. What is beta of 2 3? Integration 0 to 1. Now here this is m, and here we have to put m minus x raised to 1 into 1 minus x raised to power 2 into is the beta f 2 3 or beta 7 3. I will write integration 0 to 1 x raised to power 6 into 1 minus x raised to power 2 into this. Or if I will write here in this way, suppose I have this integral equation n into x raised to power 9 into 1 minus x raised to power 5 into e. I will write this as, yes, surely you can write this in terms of beta. This is m minus n into 6 beta n 6. But how to find value of this beta 10 and 6? We will come towards this point also. In here, I will note down this definition. Beta function, beta of mn is equal to integration 0 to 1 x raised to power m minus 1, 1 minus x raised to power n minus 1, or m is greater than 0, n is equal. What should be? Okay, I will come to this. First result, what I will, as per my definition, I will write here beta mn is equal to integration 0 x raised to power m minus 1 minus x raised to power n minus 1. This is what it is. In this result, what I will do, I will try to put 1 minus x is equal to this. Putting system 1 minus t as a t. Then we'll get here x equal to what is the value of x? X equal to 1 minus t. From this, dx equal to minus limits when x equal to 0, t becomes 1. And x equal to 1, t becomes 0. Therefore, above beta function, right? Get इंटीग्रेशन अब a इंटीग्रेशन जो है a 0 1 goes on changing because limits are varying from 1 to 0. Therefore, this is 1 to 0 x raised to power m minus 1. I'm putting value of x. 1 minus t raised to power m minus 2 into here x minus 1. I'm putting as a t raised to power n minus 1 into dx. What is dx? dx integration directly 0 to 1 because minus sign is here. I will or I will 1 minus p raised to power m minus 1 into t raised to power n minus 1 from 1 to 0. This is nothing but integration 0 to 1 and t raised to power n minus 1 into 1 minus x raised to power m minus 1 into dt. Write this equation in terms of t or in terms of x, doesn't matter, or is x raised to power m minus 1 into 1 minus x raised to power m minus 1 into dx. This is as per definition of beta function. We are knowing that beta, but this is the beta of n. First n minus 1 and then here. This is the beta n. M is here. M is here. Then we are taking m minus 1 first. M minus 1 for x only. Same thing is here. We will n here, n minus 1 or x raised to power. This is the beta nm. And what is our left hand side? Left hand side is beta nm. So beta nm. Beta mn is equal to beta nm. Mn is equal to beta. Okay, and we have to beta nm is equal to beta mn. Now henceforth I will write anything. mn or beta nm, doesn't matter because they are same. Take here another detail. We know as per definition of beta function. So this is the important relation. Beta nm is equal to integration 0 to 1 x raised to power m minus 1 into 1 minus x raised to power n minus 1 into dx. This is for our definition. What I will do, I will put, suppose x equal to sine square theta. I'm putting here. This is important. I'm putting x equal to sine square theta. That means my aim is I would like to convert this beta function in terms of trigonometric integral form. We'll see what will happen here. Now I will find here it's a derivative. Okay, derivative becomes 2 into sine theta into cos theta into square theta. What about limits? When x equal to 0, that means we are getting sine square equal to 0, sine square equal to 0 theta equal. And when x equal to 1, this gives sine square theta is equal. That means we are getting theta equal to, that means if the sine theta equal to 1, theta equal to 5. In this case, we are getting limits are varying. Therefore, this above integral becomes 0 to pi by 2 x, now I am putting x equal to sine square. This is the sine square theta raised to power m minus 1 into 1 minus sine square theta raised to power n minus 1 dx. And what is dx? This dx is 2 into sine theta into cos theta into d. This simplification will get 0 to pi by 2 and write this as sine theta raised to power 2m minus 1 minus 2 because 1 minus sine square theta is the cos square theta. The cos square theta raised to power n minus 1 into 2. I will take 2 out. Sine theta into cos theta. Now I will simplify this sine function, sine theta, and this cos square function. We'll get this as 2 into integration 0 to pi by 2 sine theta raised to power 2m minus 1. Because power is 2m minus 1 and power of this sine theta is 1. This is 2m minus 1. Similar way, for this function, cos theta is 2n minus 1 to d. Means this is our simplest form for this theta m. The mn is you can write. This is the trigonometric form of beta mn is equal to 2 into 0 to pi by 2 cos theta raised to power 2m minus 1 sin theta raised to power 2n minus 1 to d theta. Isn't it? I will now generalize this idea. First of all, again, we will recall beta mn is equal to integration 0 to 1 x raised to power m minus 1 into 1 minus x raised to power n minus 1 dx. Second result, we are knowing that beta mn is equal to beta nm. Third result, beta mn is equal to 2 into integration 0 to pi. This is the sine theta. All right. Sine theta raised to power 2m minus 1 theta into cos raised to power 2m minus 1 theta into d. Now here, these are our basic results we are getting from beta function. Now for this result, I will write here. This is my beta mn. Beta mn is equal to 2 into 0 to 2 the sine of 2m minus 1 theta into cos of 2n minus 1 theta into d. This form I will convert into integral equation form. Directly we are getting integral formula from this. Here I will put this term and this term as a Pn. Put 2m minus 1 is equal to P and 2n minus 1 equal to Q. Now from this we are getting m equal to, I'm taking 1 to this side, this is P plus 1 divided by 2 and n equal to Q plus 1. Therefore, this above result becomes, now this, I will write this result. First, I will write this term, integration 0 to pi by 2, sine raised to power p theta, then this is the beta mn. What is m? P plus 1 divided by 2, q plus 1 divided by 2 is equal to 2 into integration pi by 2. Sine raised to power p theta, cos raised to power q theta into, this is nothing but, therefore I will write this reduction formula. Sine raised to power p theta into cos raised to power q theta into beta is nothing but 1 by 2 into beta of p plus 1 divided by 2 q plus 1. This is the tested reduction formula we are getting for this 0 to pi by 2 sine theta, sine raised to power p theta into cos raised to power q theta is equal to 1 by 2 into beta of p plus 1 by 2 q plus 1 by 2. Plus 1 by 2. We will stop here for this beta function or introduction of this beta function, and we'll cover next part and example in coming week. Thank you.